Hello everyone, welcome to the first lecture of quantum mechanics, or you can say the introductory lecture of quantum mechanics. In this lecture, we will see the different topics which we'll discuss in the upcoming lectures of this quantum mechanics series. In this quantum mechanics lectures, we will see and solve and understand all the basics of quantum mechanics to the upper level and advanced level of quantum mechanics. So the first topic is the foundation of quantum mechanics. In this foundation of quantum mechanics, we will see what are the importance of quantum mechanics, why we need quantum mechanics apart from classical mechanics. So classical mechanics and why we need the quantum mechanics apart from classical mechanics. Also from uh, quantum mechanics perspective, what are the different types of experiments which leads us to know about the quantum mechanics and their properties. Then we will see the different types of experimental phenomena like photoelectric effect and de Broglie's wavelength, and then black body radiation, and then we will solve the and derive the Schrodinger equation for the wave. The second topic is the application of Schrodinger equation, where we will see the different applications of Schrodinger equation in 1D box, in rectangular potential barrier, then rigid rotator, their eigenvalue, then eigenoperators, and their solutions. The third chapter is truly on about the operators and operator algebra, how different types of operators commute with each other, what are the mathematical expressions we will see in this chapter. The fourth one is the mathematical formulation of quantum mechanics, the an elementary representation theory. Here we only see different types of matrix which will also used in mathematics, matrix formulations and matrix algebra. The fifth one is the identical particles and its spin motion. We will see the spin matrix in this chapter, which is also called Dirac matrix. The fifth, sixth one is the angular momentum and their properties, angular momentum operators. We can say angular momentum operators and their properties like Lx, Ly, and Lz. Their commutation properties and their functions. The seventh one, the seventh chapter is the time independent quantum approximation method and the stationary perturbation theory and variation methods and WKB methods. WKB method. These are different types of examples of quantum physics where we'll see how these approximation methods are useful to solve certain type of Hamiltonian and its uh, different types of Hamiltonians and their problems. The eighth one is the time dependent quantum approximation method, and where we'll see the semi-classical theory of radiation. The ninth one is the quantum theory of scattering, where we'll see Rutherford scattering, and scattering cross section. And the last one is the relativistic quantum mechanics. We will see Einstein theory and Lorentz transformation and their relativistic quantum mechanics operators with regarding this topic. So we are going to start the basics of quantum mechanics. So we'll start with foundation of quantum mechanics. So what is the foundation of quantum mechanics? So first we will see the inadequacy of classical mechanics, where the classical mechanics fails. So first we'll know though what is classical mechanics, where it is applicable. So classical mechanics applicable on the base of Newton's third law. Three laws: the first law, the second law, and the third law. The first law: if a body is stationary or moving with certain velocity, it will keep moving with velocity v or at the position of rest unless if there is a force applied, external force is applied on it. This is also called the law of inertia, the inability of body to change its position of rest and motion. Law of force, that is, we know that the rate of change of momentum dp by dt is directly proportional to force. That is, after solving this, we will find famous equation F is equal to ma. And the third one is the action of reaction force law. So for if there are two bodies, if a body acting on body 2, then body 2 will also acting on body 1. This is called action and reaction force. So these law includes concept of absolute mass, absolute space, and absolute time. That means they are fixed. The classical mechanics explain correctly the motion of celestial bodies like planets, stars, microscopic as well as microscopic terrestrial bodies moving with non-realistic speed, where speed of the particle is very less than the speed of light in vacuum. Here c is the speed of light in vacuum. So the inadequacy of classical mechanics are, these are some phenomena where the classical mechanics fails. It does not holds in the region of atomic dimension. It cannot explain the non-relativistic motion of atoms, electrons, and protons. The second one is that it could not explain the stability of atoms, which we'll see in the Niels Bohr's theory. It could not explain observed spectra of black body radiation. It could not explain the observed variation of specific heat of metals and gases. It could not explain the origin of discrete spectra of atoms, since according to classical mechanics, energy changes are always continuous. So in spite of this, classical mechanics could not explain large number of observed phenomena like photoelectric effect, Compton effect, and Raman effect. These phenomena are also not very much defined on the basis of classical mechanics, that is Newton's three laws. So we have to adopt some other branch of physics to solve these phenomena. So here we have the birth of quantum mechanics. So quantum mechanics, in the term quanta, is come from the packets of energy or bundles. Since quanta is the discrete unit of energy exchanged during the increment at the level of atom and energy particles. That means we will see in the later classes, when a electron jumps from higher level to lower level, energy is released, and this energy is in the form of h nu, and this energy is form of packets and bundles, which is in the form of quanta. So quantum mechanics is the fundamental branch of physics that originate from the failure of classical mechanics and gradually developed by the number of distinguished physics. Different types of physics give their different results. Like we see the Max Planck. The first one is the Max Planck, who give uh, the result in 1900, which is called black body radiation. So what is black body radiation? A body which absorbs radiation of all frequencies without reflecting back any radiation is known as black body, and the radiation emitted by such body is called black body radiation. We will uh, see this black body radiation in the broad manner in the upcoming classes. Next one is Albert Einstein. In 1905 photoelectric effect, he proposed the emission of electrons from the substance, usually metals, exposed to the electromagnetic radiation above certain frequency, and this phenomena is called photoelectric effect, and here quantized nature of light is discovered. The third one is Niels Bohr. In 1913 atomic energy level, electrons in the atoms occupy quantized or discrete energy levels. The fourth one we will see in this, in this mostly second or third lecture, that is Louis de Broglie proposed that all particles have associated with them, and the fact that any particle have a wave associated with it leads to the so-called wave particle duality. The fifth one, this Heisenberg will give the energy algebra of matrices. We will see in the matrix algebra. The sixth one is Schrodinger. We'll give the Schrodinger wave equation. We discuss in the first chapter Schrodinger wave equation for the free particle. And there are two types, another two types, that is time dependent and time independent Schrodinger equation. And seventh one is the Max Born, 1926 probability amplitude. He gave the probability of finding the particles. We will see in the latest class, that is probability of finding particle is mod of psi square. And then the last one is Pauli Dirac in the spin statistics. Dirac shows that the Heisenberg and Schrodinger version of quantum mechanics were equivalent, and in this they could both derive from the more general version of quantum mechanics and give rise to a Dirac matrices. Dirac matrices, we will see sigma x, sigma y, and sigma z. We will see in the chapter number 5, where is the identical particles and spin. So that's it, the introductory lecture of quantum mechanics. In the upcoming lectures, we will start from foundation of quantum mechanics, from black body radiation, and here black body, we will start from black body radiation and then photoelectric effect. So hopefully you like this video, and hoping the next video will come soon and will enjoy the quantum mechanics, the world of quantum mechanics. Thank you.